Good evening, my dear students and friends. This is K. Hanumantha, faculty in AC Engineering Academy. I am having nearly 20 years teaching experience, and I have been associated with AC Engineering Academy more than 12 years for mentoring the aspirants, those who are preparing for various competitive examinations like GATE, ESC, and state board examinations like KPTCL and Genco, Transco, various AP, Telangana, and Karnataka, Orissa, so many public these state board examinations. Now today I am here to interact with you regarding that KTPCL, how the preparation you need to do that, how you have to crack the good rank in KTPCL, right? And my subject is network theory. In this network theory, first of all, if you want to score more marks, guys, you should remember one thing. In KTPCL, definitely you should answer all the questions which are going to be under a network theory questions. Since the question paper is for 1 hour with 100 questions here. That's why you should be careful regarding this while you are preparing. Should not prepare for GATE examination how you are preparing. And one more thing, my dear students, once if you are preparing for KPTCL, you should be careful regarding that all the subjects. And one more thing I have observed while I was taking the online classes, all the students, those who are preparing for the examinations, they are having more gap here. Nothing but what? All are job holders. That's why once you keep this in your mind, whenever if you want to prepare for this, if you want to crack the good rank in KTPCL, then definitely you should approach that how the practice related with that questions which are coming under KPTCL. How we need to take it that? Because here 100 questions are there for 1 hour. This is very important here. And not only that, you are having negative marking. If you want to answer the question in the stipulated time, definitely practice is more important here. And this examination is not happening frequently. That's why you may get a doubt. How, sir, we need to practice the questions, where we need to collect these questions, where we need to extract the question bank for the particular subject. I would like to give for that, just to follow that, definitely job is with you. I am guaranteed with that. You should collect the questions for each and every subject, not only my subject here, each and every subject from the previous ESC, Engineering Service Examinations. Because if you see the Engineering Service Examinations, more theoretical questions are there, more theoretical questions. 50% theoretical questions are there. And 50% numericals which are not at all required the calculator here. Those type of questions, you can get it from the previous ESC, Engineering Service Examinations. That's why, my dear friends, you should collect that for each and every subject from the previous 15 years examinations or 15 years ESC, Engineering Service Examination. Previously, this examination is IES, Indian Engineering Service Examination. That's why don't forget, the question should be practice from the previous examinations. This is very important. Previous ESC, Engineering Service Examinations from past 15 years. Any subject, not only my subject. Now today I am here to interact with you under network theory, one of the most important topic here. This is compulsory, you will get minimum 2 questions, you will get it. Minimum 2 questions you will get it. And the topic is here circuit theorems. This is very important topic. And the advantage by practicing the all questions from the previous ESC and old PYQ, previous year questions in KPTCL, if you practice, the advantage especially for this one is, this is very much useful not only for this network theory subject, it is also useful for the core subjects as well as common subjects, which are under core subjects in electrical machines. You are using the circuit theorems. And in power systems, you are using the circuit theorems. Nothing but all the network we are going to be replaced either Thevenins or Norton's equivalent. Is it right? Guys, that's why you have to be concentrate on this topic more. Compulsory question you will get it. And while coming to these common subjects in analog circuits, in analog circuits also we are going to be used the superposition theorem as well as what it is, Thevenin's theorem also. That's why this topic is very, very important, very much weightage you are having that. That's why I would like to interact today live session with that circuit theorems from ACE Engineering Academy, That's why don't forget this, Please follow the directions which are given by each and every faculty. Definitely you will get here. Especially I am giving this advice, whatever the advice I am giving this for job holders, this is very important here. And one more thing, those who are attempting and those who are already prepared for GATE examination or ESC examinations, don't go for the GATE examination. Since GATE examinations questions are highly numerical questions. That's why my advice for those who are preparing for KPTCL, right? You should take that ESC questions. Now without late, let us start the live video session under circuit theorem topics. In circuit theorems, guys, you are having nearly 6 circuit theorems are there. Out of that, 4 are according to the syllabus. Once you see the previous year's questions in this particular examination, all the questions are under 4 theorems only out of 6 theorems. And one is the verification theorem. That also we are going to discuss today, right? Now, those 3 theorems which are, we are considering that Thevenin's theorem, Norton's theorem, superposition theorem and maximum power transfer theorem. These are the 4 theorems, the previous examination questions you will get it. And my dear friends, first of all, before going to that theorems, the 4 theorems, I want to discuss that first, what is the necessity of the network theorems for circuit analysis? What is the need of these circuit theorems? Necessity of circuit theorems for circuit analysis, right? That one we can say, suppose if it is a network is there, a 2-terminal network. These are the 2-terminal network. These are the 2 terminals, terminal 1 and terminal 2. Linear and active network. Any network, if you want to apply that circuit theorems, first you need to take that the network is, if you identify as a complicated network here. What is a complicated network? The complicated network means a network will contain several sources and multiple resistors, inductors and capacitors. Usually this will be considered if the network is having several sources, multiple resistors, inductors and capacitors are there, then this is the complicated network. For this type of network, if you want to analyze, then definitely we need to take that circuit theorems. Sir, you may get a doubt here. Sir, we are having normal techniques now. Why can't you take the normal techniques which are nodal analysis and mesh analysis? My dear students, you can do it, not a problem. But when the examiner is asked in a particular branch response, you need not go for those analysis techniques, which is mesh analysis and nodal analysis. If you take that mesh analysis and nodal analysis, there we are going to take each and every branch response. But we don't need that. We want only a particular branch. That's why the necessity of network theorems or circuit theorems are, if a complicated network, that is several sources, multiple resistors, inductors and capacitors are present, if the single branch response is desired, then we need to take that, or we have to use the circuit theorems. We need to use the circuit theorems. In order to estimate the single branch response, definitely we should take that, or we have to call, we need to recall the circuit theorems. And you may get a doubt, sir, how we know that circuit theorems are required for this analysis according to the given question? Guys, some of the theorems directly he may ask. But sometimes, according to the given data, you need to realize that this theorem is suitable for this one. This theorem is suitable for this one. Let me explain that one by one first. First, if you want to take that the circuit theorems necessity, when we need to approach the analysis with the circuit theorems, two conditions or two cases we can take it. First one is, if a linear active network is the complicated network and single branch response is desired, nothing but this is the load resistance response. It could be either voltage or current passing through this one. This is what under case 1 I can take it. First, it is a complicated network. And second thing here, this is very important. This we can do it normal techniques as well as by using the circuit theorems. While coming to the second one, this is very important. When the network is having several sources, multiple resistors, inductors and capacitors, nothing but it is a complicated network. And also, if the network is operating with the multiple frequencies, this is very important. Nothing but what? In this linear active network, some of the sources are operating with some frequencies and other sources are operating with the other frequencies. Simple, we can take it as if the network is operating with DC as well as AC sources. Normal analysis is not possible here. Remember this one, normal analysis not at all possible. We should consider that circuit theorems, under the circuit theorems or superposition theorem. Without superposition theorem, when the network is having multiple sources, if it is operating, we cannot take without superposition theorem. Superposition theorem compulsory we have to take it. Otherwise, you will not get the solutions. Here, network is operating with only one frequency. Only one frequency. Here what it is? Multiple frequencies. Case 2, I can take it. Network is operating with different frequencies. Different frequencies. Example, what it is? AC and DC. Example, we can take it. AC and DC, suppose. And as usually the question is related with what? A single branch only. Single branch response is desired. Single branch response is desired. Here for load I am considering as here this current response or voltage response, whatever it is, or power response also here, not a problem, right? In these two cases, we should recall or we need to call that in order to estimate the response, the circuit theorems, right? Let me consider that what are the 4 theorems we have to take it. Now, here we are having nearly 5 theorems here I have taken. This is the reciprocity theorem is what? Verification theorem. And here the first one is very important here, that is the superposition theorem. In the examination, he never asked that any equation or any circuit is given by using the superposition theorem, how much the current is passing through that. By using the superposition theorem, how much the voltage drop across that. He will not ask like that. You need to realize that according to the given circuit, as per that connections, you need to realize if we use the superposition theorem, within the time we are going to get it. That is the advantage. If we use the superposition theorem, within the stipulated time, we are going to answer. Definitely, we will get the correct answer. How it is? Let me take that here, the superposition theorem, first one, and the second one is here, Thevenin's and Norton's theorem. These two theorems, these two guys are friends here. You can take it from Thevenin's to Norton's, Norton's to Thevenin's, Norton's to Thevenin's. By using what? One simple technique which you have to studied in basic terminology, that is here source transformation technique. Under source transformation technique, from Thevenin's to Norton's, Norton to Thevenin's, we can convert. Right? Now, while coming to that maximum power transfer theorem, this is very important here. This is the application of the Thevenin's theorem. If you want to take that maximum power transfer in the load circuit, definitely across that load circuit, entire network we need to convert in terms of Thevenin's. That's why maximum power transfer theorem, I can take it as an application of Thevenin's theorem. This is the application of Thevenin's theorem. Application of Thevenin's theorem. Remember this one. Application of the Thevenin's theorem. Right? And guys, except this, rest of the three theorems, he will ask that. What is the Thevenin's equivalent across the load circuit or across the two terminals? Anyway, I will give the questions. Today, I am going to give these network theorems or circuit theorems. I will discuss each and every theorem out of 4 theorems. These 4 are very important. These 4 only today we are going to discuss, right? Now, these 4 theorems, first superposition theorem, some examples, right? You are ready to answer the question. That is also very important. This is the live. That's why you need to be answer those questions, right? Yeah, and next one is Thevenin's or Norton's theorems. After that, I will ask some questions. We will discuss some questions under Thevenin's and Norton's theorem. While coming to that maximum power transfer theorem also, I will give the definition and how you need to solve by using the maximum power transfer theorem, and some examples we will discuss. Finally, reciprocity theorem, what are the questions you will get under that? That also we will discuss. Let me take that one by one. Are you ready for that one? Right. Now, here, let me take that the first one is the superposition theorem. Right. This is the superposition theorem. Guys, in the examination, if you want to practice that, definitely you should have the basics. That is very important. Without knowing the definition of any theorem, you cannot apply first of all. How you have to proceed. That's why definition is more important. You should know that the meaning of the definition. Now, let me take the definition. What is that? In a linear bilateral network consisting of a linear impedances on 2 or more sources. This is very important here. Under superposition theorem, 2 or more sources. If only one source is there, there is no possibility of the superposition theorem. That's why the 2 or more sources is very important under superposition theorem. Suppose in the examination one question is given. By looking the question, suppose the network is having 2 or 3 sources are there, then there is a possibility to apply the superposition theorem. Suppose one source is there, even though it is a complicated network, if one source is there, then I cannot apply the superposition theorem. Right? 2 or more sources. This is very important. Then the linear responses at any element is the algebraic sum of all the linear responses, while all independent sources are acting alone, and rest of the sources, independent sources, are replaced by their internal resistances at ideal conditions. That is, voltage source is short circuit and current source is the open circuit. This is very important here. Right? Suppose my network is having 3 sources. If I want to find out the single branch response, that response is also linear response. This is very important. More number of questions. The theoretical question which we can expect on superposition theorem is, this is only linear responses. Come on, tell me that what are the linear responses for this one? The linear responses can be here voltage and current according to the Ohm's law, right? Now, the linear responses at any branch is the algebraic sum of all, nothing but what? Suppose my network is having 3 sources, 2 voltage sources, 1 current source is there. If you want to get it that a single branch response, first take 1 source and rest of the 2 sources should be deactivated. How we need to deactivate that? That was given there. You should replace all the other sources. What sources? Only independent sources. Dependent sources we cannot touch. We don't know that internal resistance of the dependent sources. Is it right? That's why while taking the analysis by using the network theorems or circuit theorems, we should not touch the dependent sources. We should deactivate only independent sources, not dependent sources. That's why the other sources, independent sources, can be replaced or we need to deactivate by their internal resistance at ideal conditions. You know that internal resistance of practical voltage source, independent voltage source under ideal condition is 0. Zero resistance means, you know that it is a short circuit. That's why independent voltage source replaced by short circuit and independent current source replaced by the open circuit. Why open circuit? Resistance is infinity. Infinite resistance means what? Current is zero. Current is zero means open circuit. If you do this, then definitely my network is operating with only one source. Then I can easily estimate that my required branch response. Like that, take the other sources. If all are having the same direction, take that resultant current I is equal to I1 plus I2 plus I3. Any opposite direction you are identifying with respect to that direction of the source or polarities of the source, then you need to make that as a opposite sign. This is the briefly definition, you can say that, right? That's why in this superposition theorem, you need to be identified whether the network is operating with the two or more sources or not. And he wants the linear response, or whether we are going to be estimate the linear response or not. This is the first thing we have to consider under superposition theorem. Let me take that here. The next one, what are the applications we can take it or properties we can take it under this one? See this one, the applications. This theorem is applicable for any linear networks which contains what it is, either time invariant or time variant, whatever it is, whether it is DC or AC, whatever you can take it, right? Now the second one, what it is very much useful in the analysis of circuits when the network contains large number of sources, independent sources. And also, if the branch response is required, single branch response is desired. This is very important here, right? Single branch response is required, right? And next one I would like to mention under superposition theorem, what are the limitations of superposition theorem? Limitations also very important here. The limitations of the superposition theorem. Let me consider that limitations of the superposition theorem. Right, see this one. These are very important here. The question you may get it under superposition theorem on this only. Theoretical question. And one more thing, you are having negative marking. That is very important, guys. Once if you are having negative marking for any examination, you should be very much careful. You should be very much careful. Even though if you are having concept, you may not get it correct answer. And not only that, here you should answer that question within the stipulated time. For that, practice is required. Practice makes man perfect. That is very important. That's why starting of this session, I have provided that you should collect that question from the previous ESC examinations questions. Then if you practice more, why I have chosen that ESC question means more number of questions you will get it. Plenty of questions are there. In any topic if you take it, plenty of questions are there. You can select that, you can practice that. That will improve your fastness while you are solving the question. That is very important. Theoretically as well as practical, nothing but what numerically also. That is important. Now take the next one is, what is the next second limitation? First limitation, take it. It is not applicable when the circuit contains only dependent sources. I have given, usually if the network is having only dependent sources, that network is called what? Tell me, what is that network? That network is dead network here. If you see that, that network is called what? This network, if it is contains only dependent sources, that network is called, what it is? That network is called dead network. Dead circuit or dead network. No excitation, no response. Right? Next one. What is the second one? You cannot apply the superposition theorem when the circuit contains what it is, non-linear elements like diode and transistor, etc. Non-linear elements are there, you cannot apply the superposition theorem. Right? It should be linear. Suppose you may get it out, sir, suppose diode is there, then what we have to take it? How you have to consider? Sir, diode is there, two sources are there. I want to be proceed with that superposition theorem. Then how you have to react? How we need to proceed? Under that instant, you should be considered diode as ideal. You know that ideal diode internal resistance is what? Is it 0? Is it infinity? No, you cannot decide that. That will be decided by according to the given network. Sometimes you can replace that as a short circuit. Sometimes you can replace that as an open circuit. Based on that resultant current, which is coming from the source to the diode. According to that, we can replace that diode under ideal condition of the assumption either open circuit or short circuit. Remember this one, even the diode is given, right? We can take it like that. That's why we cannot apply the superposition theorem when the circuit contains non-linear element. Diode is there, under that we cannot take it superposition theorem. If it is not mentioned, that as ideal, or internal resistance is not mentioned. Right. Now, superposition theorem is applicable only for the linear response. Just now I have given that. Sir, what is the responses, linear responses? Why you are mentioning this linear? Linear means here what? The direction or the voltage is directly proportional to current. Current is directly proportional to voltage. Guys, you know that the circuit analysis is the approximate analysis. That's why you should consider that. You should consider that all the elements, whatever it is, directly proportional to that. Resistor, inductor and capacitor, these three are linear variation when the network is operating with the finite frequency. This is also very important, right? Finite frequency. Now, by taking that linear responses, voltage and current responses can be considered. But what responses you cannot take it that? Power responses. Power is non-linear. This is just like y is directly proportional to x, y is equal to mx. This is the linear variation. This is what? A linear variation. And while coming to that, power is directly proportional to what? I square. Nothing but what? Just like this is here, y square is directly proportional to that x. Nothing but what? Y square is equal to 4ax. You know that. Most of the people, you are having that in ESET, nothing but what? Polytechnic, you may not have these mathematical fundamentals. Don't bother about that. Here we are providing that. Once you get the admission in AC Engineering Academy, definitely you will get that. You will get quality material as well as a quality teaching. No doubt in that. Once if you see that, in Telangana, AP, all the students, those who are now ADs, Assistant Divisional Engineers or AEs, in KPTCL also, in Karnataka also, they got that job because of they joined in AC Engineering Academy. You can also check it that. But if you join the AC Engineering Academy, you are getting job means it is meaningless. You should put your efforts. That is very important because you are going to write the examination. I am not writing the examination. That's why join, get the concept, practice more examples, then get the rank, then get the job. We are ready to provide what content you need to practice, what content you need to concentrate in each and every topic, right? If you do that, if you follow the directions which are given by our faculty, definitely job is with you, no doubt, believe me, right? Now, under this y square is equal to 4ax, it is the parabola. That means what? It is a non-linear responses. It is a non-linear responses. Non-linear responses, superposition theorem is not possible. Now, let me consider that some of the examples under this one, some of the simple examples here. You can do it. Now, let me take that examples. And before going to the examples, here we need to consider under linear variations, the superposition. Just now I have discussed non-linear and linear. This is non-linear. What is the linear, first of all? Actually, in basic terminology, you have a linear elements. While you are defining that linear elements, if any element which obeys Ohm's law, superposition principle and homogeneity rule. Homogeneity rule also very important here, or homogeneity principle. What is the homogeneity principle? Or simply you can say that homogeneity principle means proportionality. But what is the difference between that Ohm's law and homogeneity principle and superposition theorem and superposition principle? Let me explain that. Usually you are having idea regarding that superposition theorem is what? It is the additive principle or additive property. Homogeneity principle means what? It is the scaling property. First of all, what is the additive property? What is the scaling property? For that, while defining that linear element, it has to be satisfied superposition theorem as well as one more principle. That principle is homogeneity principle. Let me take that homogeneity principle. It is obeyed by all the linear networks only. Suppose if you think that the network is non-linear, it is not applicable. If it is linear network, in a linear network, that's why see the definition. In a linear network, if the excitation is multiplied with the k times, then the response in the other branches are also multiplied with the same multiple constant k, same multiple constant k. Now let me define that one simple example with this one. Suppose my network is having simple network here. You see this one, a T network or pi network we are considering. This is what 6 ohms and 2 ohms and 4 ohms, and this is 2 ohms, here 10 volts is there. My required response is current passing through this. Can you tell me this one? Directly I can say that, because we are having that. This total, what it is? Total resistance value, how much? Total resistance is equal to, I can take it by looking into these two terminals. By looking into these two terminals, I am able to define that R equivalent. Value how much? These are the simple numericals here. You should have this knowledge, because even though if you are not having this, because nowadays here, world is forwarded here. So many are preparing for this. Competition is more. If you want to overcome that competition, then definitely we should work. Without hard work, you will not get it. That's why with this simple, here 2 plus 4, 6. 6 and 6 parallel, how much? 3. 3 and 2 are in series, how much? 5. Now with this R equivalent value, how much you are getting that? 5 ohms. Now how much current is passing through that? 2 amperes now. Now these two are equal now. Now directly I can take it, this current is 1 ampere, very simple. Are you getting? By CDR, current division principle. Now, if you want to take that, suppose if you change this total network is what network? Definitely I can say that this is the linear network, since it is made with only resistors. It is made with only resistors. Now, by taking this 10 volts you are getting. Suppose if you want to get it for this one, the response for 80 volts or for 60 volts. How many times you are considering here? K times of 10 is equal to 80. With this K value, how much? 8. Now the response directly for 80 volts. For 80 volts, can I take directly this one? Yes, you can take it for 80 volts. Ix is equal to I dash is equal to K times of I, which is equal to what it is? 8 times of 1, now 8 amperes. You need not discuss, or you need not go for any calculations, any techniques for this one. Directly, before going to that, what we have to take it, we should ensure that this network is the linear network. If it is excited with only one source, that is also very important here. If two excitations are there, we cannot take it this. Then first you have to apply the superposition, then take it homogeneity principle, right? This is very important under this superposition theorem and homogeneity principle. Now let me take that here. What is the superposition theorem and homogeneity principle? Combinedly we can make it that element, or that is nothing but the linear element property. Now let us take that here. The linearity, how can you take the linearity? Linearity is nothing but superposition principle, which is additive property. Nothing but what? We can take it here, I is equal to I1 plus I2, or plus or minus. V is equal to resultant V1 plus V2. When two sources are exciting, two sources are present in the network, which are what sources? Independent sources, right? Now while coming to that homogeneity principle, which is the scaling property. Scaling property means what? For V volts, if we are getting that some current is equal to I. For kV, we are getting under linear K into I. Scaling property. This is the additive property. If both are satisfying by any element, that element will be considered, or that property we need to consider as a linearity. Linearity. Now come on guys, here with these two, how the questions in the examination. In previous KPTCL, some of the questions I have collected from that, from the previous examinations, and some of the questions from ESC also, which are possibility, or those questions may ask in the coming KPTCL also, right? Now let me take that those questions, some of the examples from what it is? Superposition theorem. Determine the I for that one. Let me consider that. Determine the I from the following network. How you are considering that? Before going to this, we will take it this one. Examples from the here superposition theorem, right? Superposition theorem is not applicable for what? Tell me that voltage calculations, bilateral elements, power calculations, passive elements. Tell me that. Any one of you? Come on, guys. I am not getting any response from your side. Right, very good. Power calculations. Why power calculations? Why power calculations? Why not? Why not the other calculations? Power calculations. This question was given so many times here under state board examinations. So many times it was given. Just now I have given that voltage is the linear response. This is the linear. Bilateral means also. Sometimes it is non-linear, sometimes it is linear. But the property which we are considering, what is the bilateral element? Bilateral element means it is an element. What it is? It is an element which allows the current in both directions with the same amount of current here. Same amount of current. That's why this is also here bilateral one, we can apply the superposition theorem. Passive elements, we can apply this one. But power calculations we cannot apply. Why? Because power is non-linear. For this one, simply I will give that the solution for this one. You just concentrate on this, guys. If you concentrate on this here, suppose my network is having two sources, V1, V2. Is it right? And with this, in a particular resistor, what is the current response if you want to get it that? Or power response here, if you want to get the power in resistor. Guys, remember that if you want to get the power in resistor, when the network is operating with the multiple sources, we can use the superposition theorem to obtain the resultant current in the resistor. Using the resultant current, I can estimate the power. Using the resultant current, I can estimate the power. Right? Power calculations means what? Directly we cannot add the power. Directly we cannot add the power. How? Let me apply this superposition theorem, first one. Suppose if V1 is equal to, consider, and V2 is equal to 0. We are suppressing, we are deactivating V2. Now under this instant I can take it, the current passing through the resistor is equal to I1. And power is equal to, implies P1 is equal to I1 square into R. You know this. Now while taking that here, if V2 is present or V2 I am considering, definitely V1 should be deactivated. Then the current in the resistor, if you identify as I2, then definitely I can take it the power with this current, individual current, I can estimate as a I2 square into R. If both the sources are present, nothing but what? V1, V2 are present. Then what is the resultant current? Resultant current in resistor I is equal to I1 plus I2. This is valid, but P is not equal to P1 plus P2. Why P is not equal to P1 plus P2? If P is equal to P1 plus P2, whatever the power which you are estimating by using this one, this P value how much? I square into R should be equal to this one. Why it is not equal? See this one. Suppose both are same direction, I1 plus I2 whole square, nothing but what? I1 square into R plus I2 square into R plus 2 times of I1, I2, R. Are you getting this? Now this one is not equal to this one. Why? Because I1 square into R plus I2 square into R. This P is not equal to this one. That's why power is non-linear. What term is missing in this one? This term is missing. That's why for power calculations directly we cannot take the superposition theorem. It is non-linear. It is non-linear. Already we have taken under limitations of the superposition theorem. Is it right? Now let me take the next example. See this one. If all the elements in a particular network are linear, then the superposition theorem would hold when the excitation is, good example here, this one is. These type of questions we may expect here. For this one, no calculations. Previous one also no calculations directly. Tell me that, which one is the correct? Tell me, which one is correct? I am not getting the response from you. Tell me the answer. Right. It's very simple. Either AC or DC you can take it. For anyone you can take it, this superposition theorem. For anyone you can take it here. For anyone, either AC or DC. Right? There is no rule. AC we can apply, DC we cannot apply that. Right? For AC, DC, compulsory. Both combinedly also, we should be considered the superposition theorem. We should be considered the, irrespective of the excitation here. Remember that. Irrespective of the type of the excitation or nature of the excitation, we can apply that superposition theorem. But what is the compulsory condition? At least two sources should be present, which are what? Independent sources, which are operating either same frequency or different frequencies. Same frequency or different frequency. Different frequencies means compulsory we should go for superposition theorem. Right? Very good. Next example. Right. This is the somewhat numericals, but you can manage. You can answer these type of questions within that without putting pen. Think without ink. Think without ink. This is very important. These you have to apply more for the simple calculations. Now tell me this, determine the current I for the following. Are you ready? Right. Tell me the question. Here 20 volt source, 4 ohms, 3 ohms, 6 ohms and 5 amperes given. How much this? No calculations here. Without calculations. Come on guys. Any one of you? Do the calculations. Once the calculations are, I am providing that 4 amperes given. One of your friend, Arvind Reddy given 4 amperes. Is it correct? Excellent, right. Right, 4 amperes. Very good here. It's a 4 amperes. Very simple. See this. According to the superposition theorem, single source response you have to take it. Let me take that. How you need to analyze this. First, when two sources are there, independent sources, first condition is satisfied. Now take the network. Consider only 20 volt source. You just imagine that network. 5 amperes is not there. This is open circuit. Once 5 amperes is open circuit, you know the guys. Whenever if you take that open circuit series passive element can be neglected for the circuit analysis. Open circuit series passive element. Nothing but this also we can neglect. Just imagine. Under that instant you are having only this network. I1 value you are having 20 by 4 plus 6. How much this? 2 amperes. That is what I1. Nothing but here. See that. First I will explain like that. Neglect this. Deactivate open circuit. Series passive element can be neglected. And 20 volt source 4 by 6. 2 amperes. 20 by 10. I1 is 2 amperes. Now take this one. Next take the 5 amperes. This is the short circuit. Right? Short circuit parallel passive element. But once you make here short circuit, is there any parallel element? No. This is not parallel element here. If you make this a short circuit, these 2 points are same. Under that instant, 4 and 6 are connected in parallel. And the current direction, how much current is here? 5 amperes current. Now once you make this a short circuit, tell me I2 value. By using CDR, 5 into opposite resistor, 5 into 2, 4, 20 by 6 plus 4, 10. Again 2 amperes. Both are same direction or opposite direction? Same direction. That's why if both sources are acting simultaneously, then the resultant current I is equal to I1 plus I2. Is it right? 2 plus 2, which is 4. Directly you can say that. Need not go for any calculations. Need not go for any calculations. See this. Yes or no? Now for this one, I would like to take that the solution like this. Simple. Detailed solution this is. The detailed solution means here also I can take it. Take 20 volt source. 5 amperes is open circuit. Now the network will be like this. Very simple here. 20 volt source. Within 1 minute. But I suggest you for these type of examples, don't put pen. Think without ink, directly. Right. Now from this I can take it here 20 volts, here 4, here 6. Now this is I1. I1 is equal to 20 by 4 plus 6, which is 2 amperes. Now the next one you can take it directly here. Take 5 ampere source, 20 volt source is short circuit. This is the detailed solution here. Then the network will be like this. Are you getting this? Yes or no? Here this is 5 amperes and this is 4 and this is 6 and this is I2. Now by CDR I2 you can take it now by current division rule. By current division rule, 5 into 4 by 4 plus 6. Again you are getting 2 amperes. Now finally by SPT, by superposition theorem, we can take it I is equal to both are same directions, I1 plus I2, 2 plus 2, which is equal to 4 amperes. Guys, my suggestion for this example, don't go for calculation. Once you put the pen, it is time killing. Time killing. That's why think without ink, directly. Think without ink. But if you want to get that, this is the detailed solution. This is the detailed solution. And one more thing, if you are not having that much of, you need not use superposition theorem for this one here. Without superposition theorem also, we can do it. How you can do it without superposition theorem? Let me explain that one also. You will get the 4I value. Now, how much current is entering? Only one step here. See this one? This part is okay? Right. Now for this one, 5 amperes. Here how much current is leaving? I. Now by KCL, can you define this one? How much current in this direction or in this direction if you want to take it? Once you add it, this is I minus 5 now. Can I take like in this direction I minus 5? Suppose if you take in this direction, 5 minus I. Now this one is, can I apply KVL for this closed path? This is the normal method without taking superposition. But at least one equation you have to write here. But without taking the equations, what is the method? Superposition. That is the beauty of superposition. Without taking calculations, I can take it directly. Now from this here, by KVL for this one, you can get it. How you can get it? 20, this is what? Positive to negative. 4 into 5 minus 20, 4I plus 6I, 10I. 10I is equal to here by KVL, directly I can take it here. Only one step, this one also. By KVL, 20 is equal to I minus 5 into 4 plus 6I. Are you getting? Now 20 is equal to 4I minus 20 plus 6I. Are you getting? Now 40 is equal to 10I. I is equal to 4 amperes. This is the alternate method here. But by using the superposition theorem, you can do it. By using the superposition theorem, you can do it. Now, let me consider that one more example under this superposition theorem. See this one. Good example. Consider the following statement. Superposition theorem is to a linear network in determining the current responses, voltage responses, the power responses. Which of the following statement given above are correct? These type of questions you may expect here. This is very simple. Already we have done. Tell me this. Tell me this. Very good, simple. A. Very simple. Power calculations are not. That's why option A is the correct one. Very good. You need to recollect. This is the way how you have to recollect that. Right. Let me take the next example. Right. This is the good one here. Right. If a network consisting of multiple resistors, one of which is designated as R, and two constant sources are acting simultaneously, the power consumed by R is P1 when first source acting alone, and it is P2 when the second source acting alone. Determine the power consumed by R when both the sources are acting simultaneously. This one also frequently. It was given in previous examinations, previous state board examinations. This question also given. Tell me this. Come on. Right, very good here. This is the standard equation here. Under superposition theorem, this is the standard equations. Yes or no? C is the correct one. How C is the correct one? Based on this C, you can do it this one. How it is actually how this formula is generating. This is a standard formula here. You can remember this. But how we are getting, that is very important. I can do that here by taking that two sources. Already we have seen that. Right, this one we have seen. From this I can derive that formula. Here see this one. When two sources are acting, power is P1. I1 we need to extract from this. I2 we have to extract from this. Now from that you will get it. I1 value how much in this one? I1 is equal to, let me consider that. I1 is equal to, from this one, under root P1 by R. I2 is equal to under root P2 by R. Yes or no? This is only V1 is acting. This is only V2 is acting. Right? Now you can add it now. Resultant by SPT, superposition theorem, I can take it I is equal to I1 plus or minus I2. We don't know that network how they are connected. That's why I can take it resultant current in terms of powers here. With this, I can take it that resultant power is equal to I square into R. From this, I will get it under root P1 by R plus or minus under root P2 by R whole square into R. With this, you will get that by knowing that individual powers, both are same directions, I can take it positive. Both are opposite direction, I can take it as negative. I can take it as a negative. Is it right? Yes or no? This is the way how we can extract the general formula, direct formula from this one. Direct formula from this one. Is it right? Now, tell me the next question. Examples are given. Is it okay for this one? Right. Now, right, for this one. See the question. In the above example, if three sources are acting simultaneously, when P1 is equal to 100 watts, P2 is equal to 25 watts, P3 is equal to 25 watts, determine P maximum and P minimum. Guys, this formula is valid by taking the powers, individual sources. For n sources, it is possible. This formula, nothing but what? The resultant power formula, I can take it, the resultant power formula is P is equal to under root P1 plus or minus under root P2 plus or minus under root P3 so on whole square. It is valid based on the number of sources are present in that network. Is it right? Now tell me that maximum and minimum. Tell me this maximum and minimum. Maximum value how much? Maximum value obviously all are positive here. If two are there, positive and negative, minimum. But three are there, you should be careful regarding that minimum. Maximum I can take it. P maximum value, I will take it. See this, under root P1, nothing but 100 root 100 plus 100 root 25 plus 100 root 225. I can take it as 10 plus 5 plus 15 whole square. Square is there. Nothing but what? 30 square, which is 900 watts. What about that P minimum? This is very important here. For P minimum, there are three cases. For P minimum, see this, for P minimum, we should consider, there are three cases we can take it. Is what? Under root P1 plus under root P2 minus under root P3 whole square. This is the first one. Next one is what? Under root P1 minus under root P2 plus under root P3 whole square. Third one is what? All are negatives. Under root P2 minus under root P3 whole square. Is it right? How can I take it this one? You can also consider this. See this one. Now, once you substitute these values, then definitely you will get it. This one is what? 10 plus 5 minus 15 whole square. This is what? 0 we are getting here. Next one is what? 10 minus 5 plus 15 whole square. What it is? 25 minus 5, 400 watts here. Once you are getting 0, you need not go for the other calculations. That is the advantage. This is the directly 0, you can take it. Even though if you check it that 10 minus 5 minus 15, how much you are getting? This is the 100 watts now. 10 minus 20 whole square, positive 100 watts. This is the way how you can get it, that minimum and maximum powers. But you should be remember that constant formula, the general formula, standard formula for this one. Standard formula for this one. Is it right? Right. 0 and P maximum is equal to 900 and this one is 0 watts. Clear? Very good. Now let me take the next question. Right. Next, these are the some of the examples under superposition theorem. Now let me take the next theorem, Thevenin's theorem here. Thevenin's and Norton's we will discuss combinedly. Thevenin's theorem. This Thevenin's and Norton's theorem, as per the definition, when we need to approach the Thevenin's theorem and when we need to approach that Norton's theorem. All are complicated networks, nothing but network is having multiple sources and resistors, inductors, capacitors are present. Right? Now, according to that definition of the Thevenin's theorem, in a linear bilateral two-terminal network here, like in superposition theorem, whatever we have taken, what we have taken under superposition theorem, what was the compulsory condition we have taken under superposition theorem? That was minimum 2 or more sources. Like that here, two-terminal network here, this is very important. Suppose, sir, my network is not two-terminal, then I want to apply the Thevenin's theorem. Then how you have to apply? We should make that as a two-terminal network. How you make the two-terminal network? Sir, my network is the complete network. I want to find out the current response in the 10 ohms resistor by using the Thevenin's theorem. Then what we have to take it? First select that branch where you want to find out the response. Just disconnect that branch here. In a complete network, if you disconnect one branch, then definitely that will be turned into two-terminal network. That's why make that a two-terminal network. If you want to apply the Thevenin's theorem, then apply the Thevenin's theorem. That's why here compulsory condition is what? Two-terminal network. Right? In a linear bilateral two-terminal network, a two-terminal active network can be replaced by a single voltage source with series impedance. The single voltage source value is the open circuit voltage between the two terminals, and the series impedance or resistance is equivalent resistance between the two terminals, while all the independent sources are replaced by their internal resistances at ideal conditions. Nothing but what? Independent voltage source as a short circuit, current source as an open circuit. Right? This is the way how we are going to convert the entire network as a simple network here. Thevenin's equivalent means it is a simple network which contains only two elements which represent that big network across the two terminals or across the load network, which is equivalent with respect to response. Whatever the response we are expecting from that network across that load circuit, that will give that this simple, which is a series voltage source and resistor, or simply I can say that a practical source. What source? Voltage source. Is it right? Whatever the network, big network is there, we can replace a simple network. While finding the simple network voltage source value, open circuit voltage. Usually open circuit, why we are considering that? Because the open circuit voltage will reflect the entire effect of the network when the network is having multiple sources. When the network is having multiple sources. Is it right? That's why we are making that as a single source. Under that instant, we have to consider what is the maximum effect. Maximum voltage, when you will get it? Usually for any circuit across any two terminals, if you want to know that the effect of all the existing sources across the two terminals, voltage effect, if you want to get it, usually we need to consider that open circuit. Open circuit will reflect maximum effect of the existing sources across the two terminals. That's why we are making the equivalent voltage source as Thevenin's voltage source as open circuit voltage between the two terminals. That's why, remember guys, open circuit voltage, or while you are converting that Thevenin's equivalent across the two terminals any network, first you have to apply the open circuit condition. Open circuit condition means what? Suppose if my network is like this, this is the network, this is the linear active network which is connected with the load resistance, this is the network, current is required here. First we need to disconnect this one, then only you will get the two terminal, then only you are allowed to apply the Thevenin's or Norton's. Now entire network we should replace as a single voltage source with a series resistance. See this, whatever the effect we are getting from this complicated network, the same effect we can get it from this simple network. These two are equivalent. Now under you are considering this is the Thevenin's equivalent and this is R Norton's or Thevenin's. And while taking this one is VOC. Remember this, while you are finding that Thevenin's equivalent voltage, remember this, first apply the condition, remember this one, see this. First apply the condition open circuit. This is very important here. Normal voltage is not Thevenin's equivalent. Take the condition, get the effect of all the sources across the two terminals. That will give the what? Thevenin's equivalent voltage. And while finding the R Thevenin's, we should not consider open circuit here. Should not consider open circuit. We need to consider as it is the terminals. So we need to consider as it is the terminals, and we should take it. What we will take it? We should consider while finding the, see this one, while finding the R equivalent. Why we are considering while finding the R equivalent, all the independent sources are replaced by their internal resistances at ideal conditions? Because if you want to reduce the entire networks toward the two terminals, voltage sources are there and resistance is there. I cannot reduce. If the network is passive, I am able to define that effective resistance or equivalent resistance. That's why all the independent source effect we need to deactivate. That's why we are making all independent sources, voltage sources, short circuit and current sources open circuit. Then my network will be passive network. Then based on the network techniques or reduction techniques or simplification techniques, I am able to reduce the entire network across the two terminals as a single resistance. That is the R equivalent, which can be considered as R Thevenin's, which can be considered as R Thevenin's. Remember that. Under this instant, remember that. Under this instant, we should not consider open circuit. Open circuit condition only can be applied while estimating what? Thevenin's equivalent voltage. Not all time. Not all time. Are you getting? Now the same way we can take it Norton's equivalent. The same way we can take it as a Norton's equivalent. Norton's equivalent means what? See the definition. First, see the definition. Both at a time you can discuss, because these two are dual networks here. This question you may get it. Norton's Thevenins are duals. Duality you are having that. Dual elements, dual circuits these are. Right? Now Norton's theorem statement, same here, everything. What it is? It should be linear bilateral two-terminal active network. If it is complete network, disconnect that branch where you want to find out the response. Now while finding that here, the entire network can be replaced with a single current source with a parallel resistor, or simply we can replace as a practical current source. The practical current source value how much? Short circuit path current, maximum effect. Short circuit offers what current? Maximum current. It can, sometimes it can be 0, sometimes it can be negative, sometimes it can be positive. Like that open circuit voltage also. I have discussed in basics, you know that short circuit path current can be anything. That is the decided by the other elements. Network, complicated network will reflect the short circuit path current. You may get it short circuit path current is maximum, but we cannot say that. It may be 0, it may be negative, it may be positive, it may be positive. Right? Like that open circuit voltage also. It can be negative, it can be 0, it can be positive. Is it right? That's why the equivalent resistance is same R equivalent of Thevenins. That's why R Thevenins is equal to R Nortons. R Thevenins is equal to R Nortons. Is it right? First definition is what? In a linear bilateral two-terminal active network can be replaced by an equivalent circuit of a single current source with parallel admittance or conductance. Usually parallel connection is shunt connection, as a resistance is a conductance, and impedance as a admittance we are considering that. And the single current source value is short circuit path current between the two terminals, and equivalent resistance is same. Thevenin's equivalent, Norton's equivalent, both are same. Thevenin's equivalent and Norton's equivalent both are same. And here can be replaced while taking the R equivalent, R Nortons, independent sources should be deactivated. Independent sources should be deactivated. Now let me consider that if the network is a complicated network is there, suppose if the network is like this, and it should be two-terminal network here, that is very important. This is what network? Linear. This is linear active network. Complicated network across A and B can be replaced by a single voltage current source. See this? Across A and B only. This is IN, Norton's equivalent. This is called ISC, and R Nortons is same as R Thevenins. Right? This is the Norton's equivalent circuit. And the previous one is what? Thevenin's equivalent circuit. And if the resistance is there, load resistance, how you have to estimate the load resistance? Directly by reconnecting the load, you can estimate I value V Thevenins by R Thevenins plus RL amperes. This value and this value, whatever we are considering this, in two ways you can estimate the load current which should be equal. How we have to estimate in this case? Directly by CDR, current division rule. Total current IN into opposite RN by RN plus RL. Whatever the amount of current here, we are getting the same amount of current, you will get it. The previous one under Thevenins. Under Thevenins. Is it right? This is the short circuit path current. This is the open circuit voltage. Is it right? Is it clear for this one? Now, here I would like to discuss one thing. You may get a doubt here. Why we have taken that short circuit path current can be 0, sir? How you are justifying that statement? If you want to justify that statement, then definitely I will provide that a simple calculations or simple graph for that one. You may understood. See this for open circuit and short circuit. This is very simple here, but you should know this. This is very important thing. Voltage and current here. Here current and voltage. Sir, no. Suppose if the characteristics voltage and current is 0. Current is 0 on what axis? X coordinate is 0 on what axis? Y axis. Y coordinate is 0 on what axis? X axis. Suppose if you want to be consider here, this one voltage is 0. Voltage is 0 means what? It is short circuit, no? Yes or no? On which axis? Current axis. Nothing but, see this one. In this one, I can take it here. See this one. This is the point. This is the point. Any point if you are considering that. On this total, whatever the area we have covered, under this one, voltage value is equal to 0 here. This is nothing but short circuit. Now the statement which I have provided, this value is what? Current may be 0. This value is what? Positive. This value is what? Negative. Can be. That is decided by the other elements present in the network. Right? Now, like this I can take it open circuit condition. By taking the open circuit here, current is equal to 0. Open circuit implies open circuit. On which axis? Voltage axis. Anywhere you are considering that, current value is 0. Now this value is, it can be here, this is current is 0 for all. But sometimes voltage may be 0 under this case. Here voltage is positive, here voltage is negative. That's why I have given the statement. Open circuit voltage can be either 0 or negative or positive. Like that short circuit current can be anything. It may be positive or 0 or negative. That is decided by the other elements present in the network. Is it right? Got it? Now, let me consider the properties of this one. See the properties of Thevenin's or Norton's here, right? This theorem is applicable for a linear networks only. That is the network with R, L, C elements are present. Sometimes you may get it, transformer is also network and C elements, and in this one we can also add it, transformer is also passive element. Remember that transformer is present, then you can also apply Thevenin's theorem. Right? In power system we are considering this. In transformer, three-phase transformers, and in transformer topic also we can convert that entire network as a Thevenin's equivalent. And while taking the here, in the presence of dependent sources makes the network active, and hence Thevenin's theorem can be applicable both active as well as passive networks. And finally, we need to take that Thevenin's and Norton's equivalents are dual networks here. Anyway, duality property you can take it. That session we will take later, but you should know that how we are taken these Thevenin's and Norton's equivalents. Let us take the examples. Are you ready for that? Yes or no? Right. Let me take the examples. Next example. See this one. Tell me that. Find the Thevenin's equivalent. I will provide here the network how it is. You calculate here. Network should be like this. Just now we have taken this one. Cross A and B. V Thevenin's, which is VOC. Now do it. I am giving the time for you. Don't waste the time. Tell me the answer. V Thevenin's, VOC. Tell me this. Do the calculations. It will take time, not a problem. You do that. Just slow and steady wins the race. Whenever, if you are doing the calculation, remember guys, my dear friends, while you are doing the calculation, you should be confidently how to do it. That you will get by practice only. Even though some time it will take, no problem. Slow and steady wins the race. That's why you are in the ace. If you want to join in the ace, then definitely you will get it job. Slow and steady wins the race. Right, 8 volts, and first you can take it directly R Thevenin here. Sometimes the questions, even though the next question you can see that he will ask only one element or one parameter. Out of Thevenin's, under Thevenin's equivalent, how many values you have to estimate? 2 values, no? R Thevenin's and V Thevenin's. Out of that, one he may ask sometimes. Suppose if you want to find out only R Thevenin's, no calculations here, no need calculations. Just imagine the network by deactivating the independent sources. How you deactivate the independent sources? See this one. This is short circuit, this is open circuit. Now the positions, both are in parallel. By looking into these two terminals, look there, by looking into these two terminals, how these two are? Both are in parallel. Na? 3 into 6 by 3 plus 6, right? 18 by 9, it is equal to 2, very simple. Is it right? This is the way how you have to take it, because the examination is multiple choice, that's why we should go for that. We need to be considered like that. Now let me consider the here VOC, that is very important. Once if you want to take that Thevenin's equivalent voltage, definitely we should take some calculations. At least one step you have to write. You have to practice that, right? Now let me consider that for VOC, take for VOC, that also you can get it. Why? Because you are familiar with nodal analysis and mesh analysis. Now remember that while you are taking that Thevenin's equivalent voltage, first, don't forget this, first you have to apply the condition according to the definition. As per that, I can take it current is equal to 0. Here current is equal to 0. Now take that voltage across the two terminals, and polarity is also very important here. A to B, that's why A is positive, B is negative. Now can I take it? These three are parallel, yes or no? Now can I take it? This is also VOC, na? And this element value how much is? This is 12 volts. Na? Now with one equation you are able to get it here. You can get it with one equation. How you get it with one equation? See this, with only one expression. This is open circuit. This node is connected with how many branches? 1, 2, 3, 4. Out of 4, A terminal assumption, no current is coming, right? And this current is incoming. That's why incoming currents are I am considering as is equal to outgoing current. That's why by KCL, see this, by KCL, by KCL, 4 is equal to incoming current is equal to outgoing V0 minus 12 by 3 plus V0 by 6. Some of the students they are asking, sir, how you are getting V0 minus 12? Why can't write 12 minus V0? That also you can write here. Which node voltage you are considering first? Current is starting that node only, from that node only. That is very important. Suppose if you consider 12 node is first, current is incoming, then we have to add here because this is incoming. Yes or no? Are you getting? That's why here V0 minus 12 means it is leaving. V0 minus 0 by 6 means that is leaving. That's why sum of entering current equal to sum of leaving currents. Is it right? Now from this one you will get it directly the V0 value. 4 is equal to what it is, LCM is what? LCM can you take 6? Now by taking that 6 LCM, 2V0 minus 24 plus V0 by 6. Can I consider like this? Now from this 6 into 4 24, 3V0 is equal to 24, V0 is equal to 8 volts. That's why VOC is equal to 8 volts, R Thevenin's is equal to 2 ohms. Are you getting? Very simple questions, you may get it. Don't go for the complicated questions. Don't practice that gate questions. Sincere advice. It is a time-killing process. Better to take that ESC questions. Plenty of questions are there. You can practice more questions because you cannot expect more than that. Cannot expect more than that. My sincere advice to you. Right? Now, the next one we'll consider. Is it clear? Very good, very good here. Next one, see this one. Only resistance here. This is the actually question you may get it. This is the way how the questions you may get it in KPTCL. KPTCL compulsory these type of questions only get. Without putting pen, you are able to take it. Now, between x and y, by looking into these two terminals, you look from these two terminals, right? By looking into these two terminals, deactivate, open circuit, short circuit, short circuit. Now, identify the positions. You can identify easily. How? 2 and 2 are connected in series, 4 and 2 are in parallel. That's why R Nortons is equal to 2 plus 2 parallel with 2. Can you tell me that? I think answer I got it already. Very good, very good. Now 4 into 2 by 4 plus 2, 4 to parallel, 4 by 3 ohms. Option B is the correct one. Very simple here. These type of questions you will get it. There is a possibility, 100%. Right. Other than the numericals, you concentrate on the theoretical. Numericals means simple numericals. Simple numericals because calculator is not allowed. Getting? Right. Now take this question. Consider the following statements for Norton's theorem. Consider the following statements for Norton's theorem. See that one, the first statement. Short the branch resistance through which current is to be calculated. Short the branch resistance. I think it is not correct. Branch resistance not. Voltage source should be short circuit. Now let me take the second one also. Obtain the current through the short circuited branch using any one of the network simplification technique. Yes, this is what we should be concentrated on the Norton's theorem. Norton's equivalent is a practical current source, single current source with parallel resistance. According to the definition, single current source value is what? Short circuit path current. And parallel resistance is equivalent resistance by deactivating the all independent sources. Right. Now, next one is what? Third one. Develop the Norton's equivalent current source in which the resistance in series with it. Which one? Tell me this. Which of the above statements are correct? Which of the above statements are correct? Develop the Norton's equivalent current source in which resistance is in series. Is it resistance in series? No. Resistance is not in series. Resistance is not in series. Right? That's why 1 and which one? Which are correct? Are you getting? Tell me this. Right. C is the correct one. C is the correct one. Second one is correct. Third one, once you are considering that short the branch resistance through which the current is to be calculated. And the second one is obtain the current through this short circuit, that is I Norton's only. But here Norton's equivalent current source in with the series resistance, which will be considered, this is not correct. Equivalent current source is what? It is parallel resistance here. You know that. Parallel resistance. IN is the parallel resistance. Is it right? Is it clear? Next one. Tell me this. Somewhat calculations. Even the somewhat calculations, you see this, by knowing the Thevenin's equivalent resistance, we can eliminate two options here. You can eliminate two options. Tell me the correct option. For the circuit shown, Thevenin's open circuit voltage VOC and Thevenin's equivalent resistance are equivalent at the terminals A and B respectively. First tell me the resistance value. Tell me the resistance value. Tell me the resistance. Resistance you can say here. What are the options can be eliminated? Resistance value by looking at first make the two terminals. How you make the two terminal network? By disconnecting this load resistor. We should disconnect the load resistor. How you take it? We should disconnect this one. Once you disconnect, you will get it. And make the short circuit. Under that instant, 5 and 5 are connected in parallel. This 2.5, both are in series and both are parallel. 2.5. With this, what I can say? I can eliminate that C as well as I can eliminate C and B because R equivalent is what? 2.5 na? Yes or no? Right, which one is the VOC? VOC will reflect. That's why both answers are, both the values are important for this one. Now let me take it. VOC value. Tell me the VOC value. Only one expression here. Only one expression. Tell me that VOC value. Right, 2.5, okay. What about the VOC? VOC value how much? 12.5 or 6.25? Yes. Right. Here we can go for that condition or otherwise. The alternate value or the alternate way we can solve it by using source transformation technique. Directly you can take it. How you take it directly? See this one. Voltage source series resistor. How much? 10 amperes upward direction. Parallel with this 2.5. 2.5 because 5 and 5 are connected in parallel. Now 10 ampere, 10 amperes 2.5. Now again 25, 2.5, 2.5. How much you are getting that? Again 5. 25 by 5. 5 amperes current source, parallelly 5. How much you are getting that? 5 and 5, 2.5. 5 into 2.5, 12.5 and series with 2.5. Finally, you can take it. This is the correct answer. By using the source transformation technique, you can easily get it here. Because finally, we need to take this one as a single voltage source with a series resistance. A single voltage source with a series resistance, 12.5 volts and 2.5 ohms. Is it right? Is it clear? Very simple question here, this one. By using that source transformation technique, by using STT, source transformation technique, you can easily get it here. By using the source transformation technique. Yes or no? By using the source, once again I will take it. Because all are asking that, how sir? Can I explain once again? Right here I am explaining once again. 50 by 5, 10 amperes upward direction. 5 and 5 are in parallel, 2.5. 10 into 2.5 because we are going to convert from current to voltage. 25 series with 2.5. Again 2.5, 2.5 both are in series, 5. Now again in current source, 25 by 5. How much? 5 amperes upward direction. And 5 and 5 are connected in parallel, 2.5. Now again voltage source. What it is? 5 into 2.5, 10.5 and 2.5, right? Let me consider the next example. Is it clear? This is the way how you have to analyze. Don't go for the calculations. Right, see this one? Very good example here. These type of questions can be expected. Yes or no? This one Thevenin's equivalent is given. This one we have to take it. Here Thevenin's equivalent is given. For this one, Thevenin's equivalent is given in figure 1. Now once you take it, the other one, tell me this. Figure 1, Thevenin's equivalent is given. How much it is given? 10 volts with 2 ohms resistor. Figure 1, 10 volts with 2 ohms resistor. Yes or no? And figure 2, what we have to take it? 2 ohms and 3 ohms is connected here. This is very simple. You can do it across A and B. This is X and Y, suppose if you take it. This is X and Y. These are the X and Y terminals. These are the X and Y. Remember this one. This is A and B. Now Thevenin's equivalent, open circuit voltage by CDR. Na? See this one, once you make open circuit, 2 and 3 are connected in series. How much it is? 5 na? 2 amperes na? 2 into 3, 6 volts na? Now R Thevenin is equal to, or V Thevenin is equal to by VDR, I can take it 10 into 3 by 3 plus 2, which is equal to how much you are getting that? 6 volts. And R Thevenin's parallel combination of 2 and 3, which is what? 1.2 ohms. Is it right? 6 and 1.2, how much it is? Option B is the correct one. Have you got it? Is it clear? Are you getting? This one is okay? Right. Last one here. Maximum power transfer theorem. This is very important. Compulsory question you will get on this. How you take the maximum power transfer theorem? First of all, compulsory question you will get it here. Maximum power transfer theorem, when it is applicable. This is the application of the Thevenin's theorem. According to the definition, see this definition. Definition is very important here. In a linear bilateral active network can be replaced by a single voltage source with a series resistance. That is nothing but what it is? Thevenin's equivalent. Series resistance means it is the Thevenin's equivalent. The single voltage source is the open circuit voltage, nothing but this is the Thevenin's, V Thevenin's across it, and series resistance is equivalent resistance between the two terminals, nothing but this is R Thevenin's. When the load is variable, the maximum power transfer to the source to load circuit if the load impedance is complex conjugate of the source. That means the load resistance is equal to source resistance and load reactance is equal to source reactance in opposite direction. Nothing but if source is inductive, load should be capacitive. Load should be capacitive. Is it right? This is the definition for maximum power transfer theorem. Actually guys, the question in the examination under maximum power transfer theorem, we may expect in two ways. Number one is with DC source, number two is with AC source. And the normal questions can be expected under maximum power transfer theorem is, what is the maximum power transfer theorem? Percentage of the maximum power transfer theorem. Percentage means what? Output by input. Usually 50% you are getting that. Sir, 50% you are getting. Why we are using even though you are getting 50%? That's why maximum power transfer theorem is not applicable or not useful under electrical power applications. If it is compulsory, then only we need to go for maximum power transfer theorem. Otherwise, we need not go for the maximum power transfer theorem. Okay, the questions which we are expecting under maximum power transfer theorem is based on excitation. Usually, you may get it calculation wise, numericals wise only with DC. And theoretical wise, we can expect AC also. Under this maximum power transfer theorem, we can take it 3 cases here based on the excitation. Based on the excitation. First here we are considering that with DC excitation, DC source with load is variable. This is very important here. V and these two are, this is V Thevenins and R Thevenins. If load is variable, this is very important, load is variable. RL. RL is load is variable. Then what is the P maximum? Here we are having that P maximum value is equal to V Thevenin square by 4 times of R Thevenin. This formula is valid for DC. Actually, maximum value of anything, any function if you want to estimate, how we are getting that one? How we are getting the condition? For MPT, for maximum power transfer, RL should be is equal to RS according to the definition. And I am giving that in general, any function if you want to get that maximum power for MPT, for maximum value, suppose if it is y is equal to some x square plus 3x plus 2 is there. If you want to estimate that maximum value of y for y maximum, take that dy by dx is equal to 0. Based on this, you can get it this one, RL is equal to RS and P maximum is equal to V Thevenin square by 4 times of R Thevenin. This is very important formula which we have to use. Very, very important formula under maximum power transfer theorem. Is it right? Now, under this one, here we need to go for what is the variation of the P maximum or power with respect to load. That is also very important here. You should know that by taking that maximum power load versus nothing but RL and P. It is not maximum here. This curve you will get it, bell curve you will get it here. By taking this one, the bell curve, where we are getting the maximum power, where we are getting the maximum power. See this one? This is RL is equal to RS. This is the P maximum. And you know that under P maximum value is equal to V square by 4RL. And in this P minimum or P in, it is P out, maximum power. P in value how much? See this one. In this one, if we take it, when RL is equal to RS, I value is equal to nothing but what? P in is equal to V into I now. Yes or no? I value how much you are getting? V by RL, 2RL. Now nothing but V square by 2RL. From this, I can define P in value is equal to V square by 2RL. With this, percentage of the maximum power transfer theorem is P out by P in into 100, which is equal to how much you are getting that? 50% you are getting. These are the points you have to remember under DC excitation when the maximum power transfer from source to load network. When the load is variable, this is very important. When the load is variable. If load is not variable, that is a different case. We cannot take the maximum power transfer theorem. Cannot take the maximum power transfer theorem. Is it right? Now let us take that the second condition. With AC source, load is, resistance is variable or load is variable. Load is variable means, see this one. In this, we need to consider See this one. This is the AC source. This is the ZS, RS plus J times of XS, and this is ZL, which is variable, RL plus J XL. Remember this. Are you getting this part? Is it okay? Under this one, you may get a doubt, sir, this is the load circuit. You have given that whenever load circuit is there, then definitely we should take it. The load is variable. This should be variable, no doubt in that. Sir, you are saying that variable means compulsory it is. But here two elements are there, resistance and reactance. Why can't you take that here? This resistance is only variable. Reactance is only variable. Yes, you can take it. Based on this, first one, I would like to consider that RL only variable. Second one is what? XL only variable. Third one is what? Both are variable. For this one, you just remember the formulas. Condition is what? Previous one. See this. This is the condition only. Always. From that, you can get it. One. What value? One RL value or one X value. From this, you will get finite value. If you substitute X value in this, that value is nothing but what? Y max. Y max when X value, whatever you are getting. Right? This is the way how you have to get it. The value of P maximum and the value of the variable at which value of variable maximum power is transferring from source to load circuit. Is it right? These are the possible questions. Under second case, I would like to take that only RL is variable, what it is. Only XL is variable, what it is. Let me consider that only resistance is variable. Under that instant, see this one. I would like to take directly procedure is that here. You can remember that. In the examination, he will not ask that how we are getting. Just remember, this is resistance and reactance. Total is the load circuit. Remember that. Total is the load circuit. What is the load circuit? This is the load circuit. This total is load. For MPT, what it is? dP by variable is what? dRL is equal to 0. With this, RL value is equal to under root RS square plus XL plus XS whole square. This is the direct value, we can get it. You should remember this because it is asked 2 times in the ESC, Engineering Service Examination it was asked. Engineering Service Examination it was asked. Right? This one. And if only XL is variable, that also we can take it. If only reactance is variable, nothing but how the network is same as it is. Yes. This is ZS, RS plus J times of XS. See this one. Here you will get it. Load is both here, both the elements separately. Why I am considering? Because variables are different here. Variables are different. Different variables I have taken. This is again load circuit. Now see this one. For MPT, are you getting? Same dP by what it is? dXL is equal to 0. Under that instant, XL is equal to minus XS, you will get it. XL is equal to minus XS, you will get it. Remember this one, right? And the third one, both are variable, suppose. Both are variable means what? Both the conditions should be satisfied. Here, both resistance and reactance, both are variable. Are you getting? Both are variable. And both are variable. Definitely, I will take it. See this? Both are variable. Rs plus j times of xs and RL and XL. Nothing but what? ZL is variable here. Now look here. First case is what? This is variable. Second case is what? This is a variable. Now both are variable means what? Both should be satisfied. That means what? If you replace XL is equal to minus XS, that value is going to be 0, no? Yes or no? That value is going to be 0, no? Now under that instant RL is equal to RS, we are getting RL is equal to RS and XL is equal to minus XS. For MPT, same here, for maximum power transfer theorem, condition is same, dP by d. What it is? ZL is variable. Always differentiation is with respect to variable. With this, RL is equal to RS, XL is equal to minus XS. XL is equal to minus XS. Remember that. These are the two conditions which we can take it. And from this, what I can take it? ZL is equal to ZS star. Complex conjugate. Complex conjugate. Sometimes direct questions you may get it. Right? Direct questions you will get it. This is the second case here. Under second case, 3 subcases are there. 3 subcases are there. Right? Now, the third one is, this is very important. Questions are concentrating on this. Questions are concentrating on this. What is this one? Load is only resistor here, but source is AC. Nothing but source is having reactance. Load is only resistance and source is only resistor variable. At what value of that? Guys, this is very important. Sometimes you may take it RL is equal to RS, but it is not correct. If you take it the maximum power value or at what value of variable for MPT, same condition is same here. What it is? dP by dRL. With this, what you will get it? RL value you will get it. Not RS, it is the impedance, magnitude of the source impedance. Magnitude of the source impedance. Remember this. This is the magnitude of the source impedance. Getting? Magnitude of the source impedance. These are the 3 conditions. You just remember here. First is DC. Second is AC. Under AC, load impedance is variable. Under that, 3 subcases. Load is only resistor. Only resistor means what? Bulb. Lamp is load resistance. Lamp is made with what? Tungsten. Right? It is only resistance. Right? These are the 3 cases which you have to remember. These are the 3 cases which you have to remember. Now let me consider that example. These are very important here. Within 10 minutes or 5 minutes we will complete the examples. Have you got it? Maximum power transfer theorem. These are the 3 cases which you have to remember. First one is this. Right? Second one is this. Third one is this. Okay? Right. Let me consider this. This was previous KPTC, it was given. KPTCL, it was given. Tell me this. Which is the correct option? The previous, in 2018, it was given this question. Sahana. If there is a voltage source is connected across XL, load can be anything. It can be voltage source also. Procedure is that dP by dL. Power, how you have to find out? Voltage into current across the load. Across the load. Remember that. And how to find RL in such cases? Variable, according to the variable. Right. According to the variable only. If XL is variable, differentiate with respect to XL by finding the value of PL. Is it right? Now tell me the answer for this one. What, man? It's very simple. Maximum average power or maximum average power, both are same here. Why average power? This is very important here. You should know this about average power. Output power or P maximum is always existing across resistor. Across resistor, power is also called what? Average power here. You know that I square R is also called VI cos phi. How you justify this statement? First of all, tell me that answer ZL value. Question is, an independent voltage source in series with an impedance ZS, RS plus Z amps of XS diverts a maximum average power to the load circuit. Just now we have seen load is ZL. ZL should be is what? Complex conjugate now. ZL is equal to ZS star. Very simple here. Anyway, you should know this thing. Why he was mentioned that maximum average power? P maximum is equal to I square into R. This is what? VI cos phi is what? R by Z. Na? Now V by Z we can take it. V by Z we will consider as I. Now from that I can take it I into R. Now I square into R. Both are same. Average power also same. The power which is getting across, where it is? Not air. It should be D. It is not A. For maximum power. Is it right? Is it clear? Ross, your answer should be D. It is not A. For maximum power. Right, next one. Tell me this one. These type of questions you can expect here. These type of questions you can expect. Tell me this. When the network delivers maximum power to the load resistance, when it is greater than the Norton's equivalent resistance of the network, equal to Thevenin's equivalent resistance of the network, less than the source resistance, less than the Norton's equivalent resistance of the network. Tell me this. Tell me this. Excellent. Only equal. See that how the questions which are given in the previous examination. Very simple here. Now tell me this. If the combined generator and line impedance is equal to 5 plus J10 ohms, then for the maximum power transfer to a load impedance for a generator of a constant generator voltage, the load impedance is given by which are one of the following. It's very simple. No? Which is the correct option? 5 plus J10. What do you have to take it? 5 minus J10. Very simple. See that how the questions are given in the previous examination. Next one. A voltage source is having an internal impedance of 8 plus J6 ohms, supplies a power to a resistive load. What should be the load resistance for maximum power transfer? This is the what case? Can you define this is the what case? Voltage source is having internal impedance. Tell me the answer. I am expecting from you. How much it is? Right, Rajendra is correct. Silpa, Sahana, BB, you are saying that just now I have given here. Just now I have given The case, already I have given the case. What is the case? This one. This is the case. Is it right? Are you getting? Shilpa, Sahana. This is the case. We should go for magnitude of that. Should go for magnitude of that. What is the magnitude of that? RL value for MPT. For MPT, solution for this one is what? According to what? According to case 3. As per case 3, I will take it under root 8 square plus 6 square. We are having directly, for this don't go for calculations. In AC circuit analysis, I am providing in the online classes the sum of the standard combinations. You can easily do it. You need not go for any calculation part. Some standard combinations I am providing that. With angles also. 2 angles, if you know that, then definitely the power factor, based on the power factor, existing power factor, analysis of the electrical network, some standard combinations from polar to rectangular I am providing. If you remember that, you need not go for any calculation. Directly you are going to get it. This is 10 ohms. Standard combinations are there. 8 plus J6, 8 minus J6, 4 plus J6, like that, 4 minus J3. Is it clear? Option C is the correct one. Okay. Now let me consider the next one. Tell me this. A load is connected to an active network at the terminals to which the load is connected are Thevenins and V Thevenins. Then power supplied. Go for the calculations. For P maximum. Do the calculations. Direct expressions. I have given that 4 times of R Thevenins. Tell me this fast. $60 square by 4 into 10. 15 into 6, 900. What it is? 90 watts now? Got it? Very good. Rajendra. 90 watts. Rajendra. Naik was given correct answer. Is it clear? Let me consider the next example. Tell me this. This is also very simple here. This was the previous examination question. In KPTCL it was given. The maximum power will be transferred from voltage source to the load when the source impedance is half of the load impedance. Source impedance is equal to that of the load impedance. Source impedance is twice of that load impedance. Both source and load impedances must be 0. No. Which is the correct one? Tell me that. Very good. Very good. Source impedance equal to that of load impedance. Not equal to 0. Should not get it. Reactance part equal to 0. In this one, magnitude wise it is 0. Nothing but what? ZL magnitude is equal to ZS magnitude. Even though ZL is equal to ZS, star, magnitudes are equal. Are you getting? Let me consider the next one. Is it okay? Right. Tell me this. Within 2 examples, we will conclude this session. Almost we have taken 2 hours. Actually, it is only 1 hour session. More examples, more techniques, direct techniques. If you want to get it that, then definitely you will get in the online classes direct questions. A source having internal impedance of 9 plus J12 is deliver maximum power to the resistive load. The load resistance will be same third case here, this one. Case 3. RL is equal to under root RS square plus XS square. Tell me this. Again you are giving wrong answer here. That's why you need training here. You should join. This is important. Just now I have given that it is under root RS square plus XS square, which is equal to what? 15, 9 square plus 12 square, 81 plus 144, 225. which is 15. Yes or no? Now tell me this. Tell me this one. With this, we will conclude today's session. This one also direct question. Direct question. Tell me this. Maximum power that 12 volts DC source with an internal resistance of 2 ohms can supply to the resistive load. P maximum is equal to, direct here, V square 12 square by 4 into 2, 3 into 6, 18 watts. Yes or no? Very good, very good. V square by 4 RL here. Yes or no? 3 into 6. Very good, very good. These type of questions are providing. Now see this one. For this one, the maximum power that can be transferred to the load ZL in the circuit below. This is somewhat calculations, but it's very simple even though. Here ZL is given here directly. Can I use the formula V square by 4 RL? Yes, you can use it. Why? Because the network is going to be here RL plus JXL value is equal to RS minus JXS. Nothing but what? 10 minus J50. If you do this, plus J50 minus J50 will be cancelled. Only resistive part now. That's why P maximum value, when we have to use that P maximum, if the, what it is, what value? If the load resistance is equal to source resistance and load reactance is equal to source reactance in magnitude but opposite sign. Nothing but what? This is inductive and this is capacitive. Guys, here you may get a doubt. Sir, we are considering only for this V square by 4 RL. Right? Because for the competitive examinations like state board examinations only on this. But in gate examination, sometimes he may give that if the load or the total network is not resistive, in that case also. That we will discuss in the class. That we will discuss in the class. When we cannot use this V square by 4 RL, that one also we will consider that. See this one. 50 at an angle 0 degrees, he was provided that RMS value. Circuit values are always RMS values, sir. That's why 40 square by 4 into RS value, how much? 10. How much you are getting that? 50 square. It is not 40, 50 square. How much you are getting that? 50 into 50. 250. 250 by 4. How much 250 by 4? 62.5 now? Very good. Have you given that? Is it clear? These are the questions which are given in the previous KPTCL and some of the state board examinations questions. This is the maximum way you can get it. These are the maximum level which we can expect from the network theorems or circuit theorems. Not more than this you will get it. And the detailed discussion, if you want to get it that, then definitely in online classes we are providing each and everything from the scratch level, from the basic level. We are going to get it, that, right? And in some other time, the next topic, a very important topic, transient circuit analysis also, that is very important. We will discuss the next topic in the next session as transient circuit analysis. And once you take that, then definitely directly without putting pen, you are able to get it. And guys, my sincere advice for those who are preparing, those who want to get the job in KPTCL, right? definitely you should take coaching, right? If you take the coaching, then definitely you will know how to prepare for the examination, and you need to attempt that tests, online tests, then definitely you will get perfection. Then only you can get the job. That's why 3 P's are very important here. First, presence. You should present in the class here. That is very important. Once you present, then you are able to concentrate. Second one, present and performance. This is very important. 3 P's are important. Present, first one. Second, performance. Just simply sitting on the monitor, your mind is somewhere, your eyes are on the monitor, you will not get anything. That's why performance, you should perform, you need to write that short notes, what the class is going on. That's why the second thing is what? Performance. Third one is perfection. If you satisfy the first 2 P's, then only you will get the perfection. Then only you will get perfection. Then with this you will get a command on the subject. Then definitely you will get the job in KPTCL. That's why all the students or my dear friends, you please join coaching and concentrate on that and get the perfection and get the job. All the best. Thank you. Thank you very much.